If we see machining as a whole, what is happening at all length level, at all length scales, this process is very complex. Lot of things are happening. So means if I am thinking machining is a simple or complex process, if I am looking it at as a whole, it is a very complex process to model. But every time I need not to go at all the details. Why? Because user or a scientist should decide what I want. If I am only interested in cutting forces, what kind of model is needed? If I am interested in chip formation mechanism, what kind of model is needed? If I want to model tool wear, at what length scale I need to model it. So if you see this process as a whole, it is very complex process. I will explain it quickly. See, process condition for machining is basically we need to apply cutting velocity to the cutting tool. We need to define undeformed chip thickness, or we call it as a feed or depth of cut. Then there are chip formation mechanism, whether a deformation is more in primary deformation zone and in secondary deformation zone, whether the chip is forming serrations or not, whether it is continuous or segmented or sawtooth type. That is all comes under chip formation mechanisms. Tool geometry, what I am considering in tool geometry, rake angle, flank angle, cutting edge radius, or any other features if I am modeling it as 3D. What kind of friction law, whether it is a constant friction over the rake face and tool chip interface, or I am considering sticking and sliding kind of friction behavior, that will comes under friction. And due to friction, how temperature is increasing, what kind of law I am using, conversion of frictional energy to heat energy. Then tool wear, what kind of tool wear I am going to consider, only at the rake face or flank face, flank wear and crater wear, whether I am going to model it or simply I will use cutting tool as a rigid body, that is on user. Whether I am really trying to capture the machine surface properties. Once my cutting tool removes the unwanted material, what will happen to the finished surface? If there are showing any cracks, any damage on the machine surface, how the surface finish is. Then whether I am going to extend it, whether this damaged finished part having any cracks developed on it, or whether these cracks will propagate when this machined component is in application. That will all comes under fracture mechanics. So the study of the propagation of cracks due to this machining operation. What level of material constitutive model I am going to use, whether is it okay if I will go with continuum mechanics, or do I need to consider at all the grain structure, dislocations, or even at the further downscale at the atomic structure or crystal structure? Is it really needed for all the length scales? See, theory of dislocations. So if I'm going at that level, a really model will be very, very bulky, or maybe our regular constitutive equations and the strength that we have determined from the tension test may not be feasible, because size effect will come into picture. And effect of microstructure that I told you, whether I'm really considering the size of grain, the orientation of the grain boundaries. So you can see many things are involved. Whether there is phase transformation due to this high temperature pressure conditions. So modeling these things completely it itself is a very, very challenging and a very long problem. It's not like it is solved in a day or something year. People have started this from 1920, 1930s. Still they are researching on it. Lot of new things are coming, lot of new materials, new tools, coated tools, super alloys. This constitutive equation, same constitutive equation, same theory may not be applicable everywhere. So it is still going on. So as a modeling engineer, we need to figure out what kind of details I want, what kind of output I want. That's why two fundamental questions I raised here. Without answering these two questions, one should not directly go to any model, not only machining model I'm talking about, any model. What is the objective of model? What you are looking for? You should define this very clearly, because one model will not give you all the required outputs. Not possible. If I'm interested only in cutting forces, maybe you need a very simple model. You are also involved, also want chip formation type, its mechanism, maybe you need more detail. If you want to see the heat generation in different regions while machining, maybe you need some more details. You want to see, let's say, how thermal properties, how mechanical properties are affected due to machining process, you may need certain more details. So the objective of the model is very, very important. If you don't want all the things at once, unnecessarily, don't complicate the model. This is fundamental rule of modeling. Don't complicate model if it is not necessary. Otherwise, what will happen? Otherwise, in finding or in giving more and more detailed input, you may forget crucial one. That's why decide what outputs you are looking for first, and for that output, what kind of model is sufficient. If you are unable to figure out, see literature, see textbooks, and decide what kind of model is sufficient to get the required information that I am looking. What is the advantage of this unnecessary complication that I mentioned? If your model is simple, then it is easy to debug. Simple models are easy to debug, and they are easy to extend also. Once you have simple model and it is working fine, then you can easily extend it. One by one physical phenomenon you can always add. So it should be like a ladder process, your model. Go step by step. Don't directly jump to the fifth or sixth step. Otherwise, you don't know then why this error is coming or why your model is not showing accurate results. So start with very simple assumptions and then remove assumptions one by one. Then you will have a very good model at the end. And you will know all the stages, how this model is built. So in that way, I gone through all this thought process and trying to give you simple stages how one can build, let's say, a simple machining model first. How to make it more and more accurate gradually, that I will show you.